Bob, your book's called The Counter-Consensus. That doesn't sound like the Bob Carter I know. It's almost like there are no experts, there's no consensus, we're all in the dark.
We're not all in the dark. The problem is not there are no experts, there's lots of experts, as there is on any complex scientific subject. And quite appropriately, they have different views, but they're scientists. So those views have to be anchored in what we call empirical science, which means in observations, be they observations of nature or be they experiments in the lab. And that's what's lacking in the public discussion of the climate change debate, is far too big a concentration on speculative computer models about what might happen in the future, and far too little attention paid to the actual data about the weather and the climate system around us. And that shows that there was indeed a warming, a mild, gentle warming, nothing alarming at all, in the late 20th century for about 20 years. And that warming reached a peak in a big El Nino year in 1998. Since then, it's been very gently cooling. No evidence at all that any of these changes have anything to do with human activity or influence. These are natural climatic changes.
Now, I know in the book you talk about there being 3 different realities.
Yes, in the book. The book is structured that way. There's as many sides to this story as there are qualified scientists looking at it. It's a very complicated issue. There's more than 100 areas of knowledge and subdiscipline speciality that you need to cover if you're dealing with climate science. There's the alarmists, the people that advise the Intergovernmental Panel on Climate Change, who are saying, we've got a real problem here with this global warming, it's going to be dangerous and we've got to stop it. And on the other hand, people who are called deniers that say there's no trouble whatsoever. In fact, the huge majority of scientists sit in the middle between those 2 viewpoints. And as one of those scientists, I find it useful to talk about 3 realities of climate change, not sides, but 3 different realities. Firstly, there's the science reality, where scientists go out and they measure things and they observe things and they look for mathematical relationships between them. That's science reality. The second reality, which actually dominates the public debate largely, is the outputs of speculative computer models. Now, these computer models basically are a black box, mathematical box, into which you put what you know about the physics of the climate system. And we know a lot about the physics of the climate system, but we don't know everything. So we don't have a theory of climate. We do our best. We put all those mathematical relationships in there. We wind the handle, the computer chugs away, and then it says, in 100 years' time, the temperature is going to be this. Now, that is not a prediction. It is not a forecast. So you might say, well, what's the use of using computer models at all for 100 years away? It's speculative. Yes, it is speculative, but it's still very useful, because in doing the calculations, in writing the computer program, you have to try to understand the climate system. You have to understand all the physics. And the scientists that do this, or they're not scientists, a lot of them, the engineers that do it and the software writers, are very skilled people, and they can produce a range of possible outputs by changing things in the model. They can see different outputs 100 years down the line, and then you can see which part of the model is reacting to that, whether it's the humidity or the winds or the precipitation, and you can play with it. In fact, the climate models are PlayStation 4 computer games. And I don't say that to put them down. That's a very important function in science, is playing with the data and seeing it. But the idea that these things will produce a prediction of what climate will be like in 100 years' time is quite simply silly. And the fact that governments around the world, including the New Zealand government, takes these projections of perhaps if, what if, as actual predictions is really dangerous public policy. So then the third part of the book is what I call the socio-political or social and political reality, because it's true that the man in the street or the woman in the street quite rightly have their own views on this. I'm not expert in that area, but I look at what's going on and I am troubled by it. And I'm troubled by it, especially what happens in the education system in terms of indoctrinating and imprinting children, because it has become hysterical and it's become pathological. It's removed from the science reality. So the last part of the book is where to from here. What the IPCC has advised and what the government has picked up, both Helen Clark's government and now John Key's government, is an emissions trading scheme to putatively try to prevent some future warming. Now, well, let's call that Plan A. Plan A has been tried. The Kyoto Protocol was about Plan A. We spent a couple of $1 trillion in Kyoto. It has not made one blind bit of difference. So Plan A doesn't work. We've tried it. Furthermore, it won't work because it's been tried in detail at individual country level. And the Scandinavians, Norway, has had a carbon dioxide tax, since the early 1990s of around $20, $30 per tonne, which is the sort of level that governments think, well, we can impose that on the hip pocket and people won't squeak too much. So they've had that since the early 1990s. What's happened to the carbon dioxide emissions for Norway? They've gone up by 15%. So Plan A hasn't worked under Kyoto. It won't work at the level of individual countries because we've tried it, and it can't work because of the basic physics of the situation, which is not explained to the public. The basic physics is this: the more carbon dioxide you emit, the less the incremental warming for the extra carbon dioxide. So you can double carbon dioxide and you can double it again, and the temperature response is not a line like this. It's what's called a logarithmic curve like this. And the higher up it you get, the less bang you get for every carbon dioxide buck. So the physics says that Plan A can't work. We desperately need a Plan B. Plan B has to be adaptation to climate change as it happens. If you're prepared to adapt to natural climate change, which has a huge range of variation, by definition, you're prepared to adapt to any human-caused change which might eventuate in the future. And it might. It hasn't yet, but it might. To try to stop climate change is as sensible as trying to stop this volcano that's erupting in Iceland.
We've got the Pacific Islands who seem to be sinking so that the sea level appears to be rising. There appear to be bigger storms brewing in the Pacific and the Atlantic and coming ashore. That there appear to be climate changes, and so you can understand why people...
I can. When you say appear to be, I would rephrase that. There are spun to be. And taking those ones that you raise in particular, let's start with the first one, sea level change in Pacific Islands. A Pacific Coral Cay island, or an atoll, is not so much a thing as it is a process. The process is marine erosion in shallow water on coral reefs, breaking bits off. The key part of the system is actually biological, not physical. It's parrotfish. And parrotfish graze on the coral animal, and of course that includes the skeleton. And the skeleton, broken up into little bits of sand, passes through the gut, and that's where the coral sand comes from. There's a sandbank there, and if it's there long enough, and it's on top of an extinct volcano, that's why the water's shallow. If that sandbank's there long enough, the odd coconut will wash up. And then they will establish a small freshwater lens from rain, which will nurture the growth of palm trees and vegetation within 1 metre or 2 metres of sea level. Naturally, over periods of decades to hundreds of years, that atoll moves around, and the same forces, tide, wind, wave, that created it, will move it and sometimes destroy it. The more people you put on such an island, the more investment you put in, the bigger your risk hazard. Because they start using resources, they start digging holes, they start exploiting the groundwater, and many of those things cause subsidence. There is no evidence for recent sea level rise in the major Pacific atoll region, but there is evidence, which we see on television news, of marine storm transgression, and that's largely caused by changes that we've made on those atolls themselves. The sea level rise thing is a tricky one, but there's quite good records now for the last 25 years, and what they show is sea level varies up and down in concert with La Nina, El Nino cycles. Behind that, there may also be a very slow, long-term trend, but it's got nothing to do with humans, it's a natural.